Okay, now we're going to solve these systems, but not by graphing like we did on 4a and b. So I'm going to use substitution on this first one because it's set up for substitution. So I see x equals negative 2y, so I'm going to replace x with negative 2y. So 6 times negative 2y, my kids are arguing, so I'm so sorry, minus 3y equals 5, and I'm going to solve. So this gives me negative 12y minus 3y equals 5. That gives me negative 15y equals 5. Divide by negative 15, divide by negative 15. And I get y equals negative 1/3. So I know that that is half my answer because my answer is an x comma y. It's a point. So negative 1/3. Well, I'm going to plug it into my substitute. So x equals negative 2 times y, which is negative 1/3. And I know 2 negatives equals a positive, and this becomes 2/3. So there's my answer for A. Now let's try B. Well, B are both in standard form, so we're going to use what we call big addition or elimination. Okay, well, I need to make either the x's match or the y's match. So I look at the y's, and I already have a negative and a positive. So remember, we're trying to make a zero pair. And I can turn a 3 into a 15 and a 5 into a 15. So 3 times 5, and then 5 times 3. Well, 5 times 4x is 20x. 5 times negative 3y is negative 15y. 5 times 7 is 35. 3 times 7x is 21x. 3 times 5y is positive 15y. 3 times 2 is 6. And now comes the big addition. Well, this zeroes out, and I get 41. 41x, divide both sides by 41, I get x equals 1. So I got half my answer. So I need to pick one and plug it in to find y. So I'm just going to do this bottom one. 7 times 1 plus 5y equals 2. So this is just 7, so minus 7, and I get 5y equals negative 5, divide by 5, divide by 5, I get y equals negative 1. So positive 1, negative 1.